conductors originating from the tap can or limiter lug cabinet and terminating at the 500 amp circuit breaker can be sized based on 1.25% of the fire pump's full load amps. The reasoning behind this lies in the specific application of the conductors. They are dedicated to supplying power to the fire pump, and therefore, the National Electrical Code provides specific guidelines for their sizing to ensure reliable operation of the fire pump system. The 25-foot tap rule is not applicable in this scenario, primarily because of the proximity of the tap can or limiter lug cabinet and the 500 amp circuit breaker. Both components are located within the same room, significantly reducing the conductor length. The 25-foot tap rule is fundamentally designed to mitigate voltage drop issues associated with extended conductor runs. Since the conductor length in this installation is unlikely to exceed 25 feet, the voltage drop concerns addressed by the tap rule are minimal. It's important to understand the purpose of the 1.25% rule in the context of fire pump installations. This rule establishes a minimum sizing requirement for conductors supplying a fire pump. Its primary objective is to ensure the conductors possess sufficient capacity to manage the substantial inrush current drawn by the fire pump during startup. Fire pumps typically exhibit a high locked rotor amperage (LRA), significantly exceeding their full load amperage floor. The 1.25% rule ensures the conductors are adequately sized to accommodate the surge of current without experiencing excessive voltage drop or overheating. To elaborate further, firstly, understanding the full load amps floor of the fire pump is crucial. This value represents the steady-state current the pump draws when operating under normal conditions at its rated load. This information is typically found on the fire pump's nameplate. Secondly, calculate 1.25% of the fire pump's full load amps. This calculation determines the minimum allowable ampacity for the conductors. For instance, if the fire pump has a full load amperage of 100 amps, then 1.25% of 100 amps equals 125 amps. Thirdly, select conductors with an ampacity equal to or greater than the calculated value. The ampacity of a conductor is its current carrying capacity as specified by the National Electrical Code. Conductors must be chosen based on their ampacity rating at the appropriate temperature rating for the application. Fourthly, consider the conductor's insulation type and the ambient temperature. Different insulation types have different temperature ratings. The ampacity of a conductor decreases as the ambient temperature increases. Therefore, it's essential to select conductors with an appropriate insulation type and to adjust the ampacity rating based on the ambient temperature. Fifthly, reference National Electrical Code Table 310.15. This table provides ampacity ratings for various conductor types and sizes at different temperature ratings. Use this table to select the appropriate conductor size based on the calculated ampacity and the conductor's insulation type and temperature rating. Sixthly, ensure proper overcurrent protection for the conductors. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect conductors from overload in short-circuit conditions. The overcurrent protection device should be sized to protect the conductors in accordance with the National Electrical Code requirements. Seventhly, consider voltage drop. While the 25-foot tap rule may not apply, it's still important to consider voltage drop in the conductor run. Excessive voltage drop can negatively impact the performance of the fire pump. The National Electrical Code recommends limiting voltage drop to 3% for power circuits. Eighthly, use appropriate termination methods. Proper termination methods are essential for ensuring a reliable and safe electrical connection. Use connectors and termination methods that are listed and labeled for the specific conductor type and size. Ninthly, install the conductors in accordance with the National Electrical Code requirements. This includes proper support, spacing, and protection from physical damage. Tenthly, document the conductor sizing calculations and installation details. Proper documentation is essential for future reference and maintenance. This documentation should include the fire pump's full load amps, the calculated conductor ampacity, the conductor size and type, and the overcurrent protection device size. To further clarify the application of the 1.25% rule, consider its significance in relation to the fire pump's motor starting characteristics. Fire pump motors, like many large motors, draw significantly higher current during startup than during normal operation. This inrush current, also known as the locked rotor amperage, LRA, can be several times the full load amperage floor. The 1.25% rule ensures that the conductors are sized to handle this inrush current without experiencing excessive voltage drop. Excessive voltage drop during motor starting can cause the motor to stall or fail to start, compromising the fire pump's ability to perform its intended function. The 1.25% rule provides a safety factor to account for the inrush current and ensure reliable motor starting. Furthermore, the mineral insulated cable mentioned plays a vital role in fire pump installations, particularly in ensuring circuit integrity under fire conditions. Mineral insulated cable is constructed with copper conductors encased in a copper sheath with magnesium oxide mineral insulation between them. This construction provides exceptional resistance to heat and fire, making it ideal for critical circuits like those supplying fire pumps. The requirement to size the mineral insulated cable at 1.25% of the fire pump's full load amps is consistent with the overall objective of ensuring reliable fire pump operation. Even under fire conditions, the mineral insulated cable will maintain its circuit integrity, allowing the fire pump to continue operating and providing essential fire suppression capabilities. In addition to the sizing considerations, it's important to emphasize the need for proper installation practices. Conductors must be installed in accordance with the National Electrical Code requirements to ensure safety and reliability. This includes proper support, spacing, and protection from physical damage. The tapkin or limiter lug cabinet is a critical component in the electrical service for the fire pump. It serves as the point where the fire pump circuit taps off from the main electrical service. The tapkin typically contains fuses or circuit breakers to protect the fire pump circuit from overcurrent conditions. The 500 amp circuit breaker provides overcurrent protection for the conductors supplying the fire pump. It is sized to protect the conductors in accordance with the National Electrical Code requirements. The circuit breaker must have an interrupting rating sufficient to handle the available fault current at the point of installation. The selection of the appropriate overcurrent protection device is crucial for ensuring the safety and reliability of the fire pump system. The overcurrent protection device must be sized to protect the conductors from overload and short-circuit conditions, while also allowing the fire pump to start and operate without nuisance tripping. It's also essential to consider the coordination of the overcurrent protection devices in the fire pump circuit. Coordination ensures that the overcurrent protection device closest to the fault will trip first, minimizing the impact on the rest of the electrical system. In summary, the conductors from the tapkin or limiter lock cabinet to the 500 amp circuit breaker can be sized based on 1.25% of the fire pump's full load amps. This rule ensures that the conductors are adequately sized to handle the high inrush current that the fire pump will draw when it starts up. The 25-foot tap rule does not apply in this scenario because the tapkin and circuit breaker are located in the same room. The mineral insulated cable provides enhanced fire resistance for the fire pump circuit. Proper installation practices and overcurrent protection are essential for ensuring the safety and reliability of the fire pump system. Furthermore, consider the implications of using a fire pump controller. A fire pump controller is a specialized control panel designed to manage the operation of a fire pump. It provides features such as automatic starting upon detection of a fire, monitoring of pump performance, and alarm annunciation. Fire pump controllers often incorporate sophisticated motor starting methods, such as reduced voltage starters, to minimize the inrush current drawn by the fire pump motor during startup. These starting methods can reduce the stress in the electrical system and improve the reliability of the fire pump installation. When using a fire pump controller, it's important to ensure that the controller is compatible with the fire pump motor and the electrical system. The controller must be properly sized to handle the fire pump's full load amps and locked rotor amperage. The controller must also be listed and labeled for fire pump applications. Another important consideration is the emergency power supply for the fire pump. Fire pumps are often required to be connected to an emergency power source, such as a generator, to ensure continued operation during a power outage. The emergency power source must be capable of supplying sufficient power to operate the fire pump at its rated capacity. The transfer switch that switches the fire pump from the normal power source to the emergency power source must be listed for fire pump applications. The transfer switch must be designed to automatically transfer the fire pump to the emergency power source upon loss of normal power. Regular testing and maintenance of the fire pump system are essential for ensuring its reliability. The fire pump should be tested regularly to verify that it starts and operates properly. The electrical connection should be inspected for tightness and corrosion. The overcurrent protection devices should be tested to verify that they trip properly. Fire pump controller should be inspected and tested in accordance with the manufacturer's recommendations. It's also important to maintain accurate records of all testing and maintenance activities. These records can be used to track the performance of the fire pump system and identify any potential problems. By following these guidelines, it is possible to ensure that the fire pump system is properly sized, installed, and maintained, providing reliable fire protection for the building. The National Fire Protection Association (NFPA) 20 standard for the installation of stationary fire pumps for fire protection provides comprehensive requirements for the design, installation, and testing of fire pump systems. Consulting NFPA 20 is essential for ensuring compliance with industry best practices and applicable codes and standards. The local authority having jurisdiction, OJ, typically enforces the National Electrical Code and NFPA 20. It's important to consult with the local AHJ to determine any specific requirements or interpretations that may apply to the fire pump installation. The design and installation of fire pump systems should be performed by qualified and experienced professionals. These professionals should have a thorough understanding of the National Electrical Code, NFPA 20, and other applicable codes and standards. They should also have experience in the design and installation of fire pump systems. To further clarify the requirements for fire pump conductors, it's important to understand the difference between feeder conductors and tap conductors. Feeder conductors are the conductors that supply power from the source of supply to the overcurrent protective device. Tap conductors are conductors that tap off of a feeder and supply power to a load. The 1.25% rule applies to both feeder conductors and tap conductors that supply a fire pump. However, the 25-foot tap rule only applies to tap conductors. The 25-foot tap rule allows tap conductors to be sized smaller than the feeder conductors under certain conditions. The conditions for the 25-foot tap rule are as follows. Firstly, the tap conductors must not be longer than 25 feet. Secondly, the ampacity of the tap conductors must not be less than 1/3 of the ampacity of the feeder conductors. Thirdly, the tap conductors must be protected from overcurrent by an overcurrent protective device that is rated or set at not more than the ampacity of the tap conductors. Fourthly, the tap conductors must terminate in a single overcurrent protective device that will protect the load. In the case of a fire pump, the tap conductors would typically terminate in the 500 amp circuit breaker. However, as previously discussed, the 25-foot tap rule does not apply when the tap can and circuit breaker are located in the same room. Therefore, the conductors from the tap can to the 500 amp circuit breaker must be sized based on 1.25% of the fire pump's full load amps, regardless of their length.